Yeah. Thank you very much. I wanted to talk about an issue that is not often debated in the present North American view or European debate, namely the monsoonal climate. I think it's an important regional climate event, perhaps the most important regional event in South Asia and India, and I felt it is important to talk about it as it influences perhaps 4 billion people in the world. I just have an abstract here that reveals that the droughts and floods in the Indian monsoon, based on a 200-year excellent data set, have no link with global warming. Just some general notes. Indian and Asian monsoon is the largest seasonal abnormality in the global climate system. Indian Asian monsoon affects about 4 billion people of South Asia. Timely arrival and well-distributed rainfall during the summer season, May to October, is critical for agriculturally dominated countries of South Asia. Climate models have achieved only a limited success. Most climate models project monsoon circulation to intensify in a warmer world. In reality, monsoon circulation has weakened in the last 50 years. Some basic facts of Indian monsoon. June to September is the Indian monsoon season. Rains most important for the whole of India for agriculture. Mean rainfall for the India as a whole, about 90 centimeters. On West Coast, Mumbai, Goa, and Kerala coast, about 150, 200 centimeters in just those 4 months. Central India, 100 and 125. Northwest India, 50 centimeters. This is the map of India. As you can see, on the West Coast, 50 to 100 to 125 centimeters. Central India, about 100. Northwest India, a little smaller. Right on the top northeast, there is a location called Cherrapunji, the wettest spot on the earth. Highest, lowest rainfall. Highest one-year rainfall at Cherrapunji, 2,646 centimeters in 1 year. Highest one-month rainfall at Cherrapunji, 930 centimeters, 400 inches, July 1861. Highest two-day rainfall in Bombay about 5 years ago, 105 centimeters. And if you recall, Al Gore called this, oh, this is the global warming impact. No, there have been so many such instances before. Lowest seasonal rainfall, 33 millimeters in Rajasthan, as well as 49 in West Rajasthan. Both were severe droughts in the Indian monsoon. Now, this is the variation, interannual variation for a 200-year-long excellent data set. As you can see, some of the major flood years, 1892, 17, 1933, 1961, 70, 75. Some of the major drought years, 1868, 77, and so on. There is almost no relation, no trend, nothing of the kind. Now, large-scale controls of the Indian monsoon. ENSO phase in the equatorial Pacific. A severe El Nino is often linked and it produces a severe drought. For example, 1941, 1972, these were El Nino years. They produced severe droughts in the Indian monsoon. Eurasian snow cover previous winter. A heavy Eurasian snow cover produces a weaker monsoon. Equatorial stratospheric wind oscillation, QBO, it is often called by meteorologists. That also influences the monsoon. And the new parameter, not really new, but newly perhaps discovered and linked to Indian monsoon, is called the Indian Ocean dipole. There is a warm and cold air on two sides of the equatorial Indian Ocean. Regional controls of Indian monsoon, the depressions traveling in the Bay of Bengal, traveling along the axis of monsoon trough. On the west coast, a few Arabian Sea depressions, particularly in the pre-monsoon season, brings in the strengthening of the monsoon, and the Western Ghats, the Western mountain chains, also produces rains. Now look at the El Nino. As you all familiar with this, the 1997 stands out. That was the most intense El Nino in the last 25 to perhaps 100 years. This is the Another representation of that Indian monsoon, or rather El Nino, a strong El Nino. You can see the warm water that impacted worldwide weather anomalies. This is the QBO, quasi-biennial oscillation, somewhere around 20 to 25 kilometer level at the equatorial region. This is caused, we do not know full mechanics as to why it is caused, but we have a 26-month approximate oscillation from easterly to westerly. This is the Indian Ocean dipole. If the dipole is positive when on the west Indian equatorial ocean is warmer than the east equatorial Indian Ocean, and negative when the vice versa. A positive dipole produces a good monsoon, it enhances convection. A negative dipole, that is when East Indian Ocean, equatorial Indian Ocean is warmer, it suppresses convection. Eurasian winter snow cover, Henry Blandford, the first Met reporter, identified adverse impact of heavy winter snow on subsequent monsoon rain. Sir Gilbert Walker used snow cover as one of the important parameters. Barnett et al. Simulated snow monsoon adverse relationships using climate models. But in general, what we have noticed is that a very heavy winter snow cover during the previous winter produces a weaker monsoon. Now, this is a very enigmatic, important jet stream called tropical easterly jet stream. Its general flow is here. This is at about 100 knots, 15 kilometer level, a very powerful jet stream. It evolves because of reversal of north-south temperature gradient. The Himalayan regions warm in the pre-monsoon months. The Indian Ocean stays cooler, and you have a easterly jet stream. The jet stream completely disappears by October. Now, as you can see, the top is the Indian monsoon rainfall anomaly. The bottom is the T statistics. If you take the Kramer T statistics for running means, if you take 11-year running means, then this is what the T statistics shows you. What it shows is that there are regions or there are decadal variability of the Indian monsoon. Plus year for many years, negative for many years. This also shows in Indian monsoon rainfall data if you take 11-year running means. And what it means is that the Indian monsoon behaves more on a decadal time scale, independent of global warming or other impacts. Now, major floods and droughts, as you can see, there were about 14, 15 floods, more droughts. The most severe flood was 1961. The most severe drought was 1877. It was that severe drought that prompted Henry Blandford to write about Himalayan snow and monsoon connection. That paper was 1884 Blandford, and it was only in 1989 that Barnett and others modeled it through climate models and showed that indeed a heavy snow cover produces a weaker monsoon 4 to 6 months following that. Now, this is the IPCC well-known diagram, as you all know. Temperature rising, but there is also a cooling effect. Yes, I understand. Now, I want to show you, I have taken two groups, 51 to 75, when the mean temperature was declining, or 81 to 2005, when the mean temperature has been increasing. So what do we get? During the 51-75, we have 4 floods, 3 droughts, mean rainfall 917 millimeters. During the 81-2005 warming period, there were only 2 floods, 4 droughts, mean rainfall 888. So what we find is that summer monsoon was stronger when the mean temperature of the earth was declining. The summer monsoon has become weaker in the last 25 years, or possibly last 50 years. And based on that, I have produced a schematic drought and a flood model. So what I'm saying is that the top shows the drought, which means you have a tropical easterly jet, which is a sort of a weak easterly because of very heavy snow cover previous. QBO easterly phase, and it has been shown that whenever the QBO is an easterly phase, it is always associated with a drought or a low monsoon. On the bottom, I have shown, okay, Indian Ocean dipole, a negative phase that is warmer in the equatorial East Indian Ocean near Indonesia, and cooler on the Arabian side near Somalia. Flood an Indian Ocean dipole in the positive phase, it enhances the convection, and my argument for this is that the top drought in a two-dimensional flow, it suppresses the convection. There is a subsidence from the top to the lower levels. In the bottom case, flood monsoon, there is this increased convection. And monsoon is primarily a convectively driven phenomenon. Now, this is the severe drought, 2009. Climate models predicted a normal monsoon in the month of April. They were wrong. 2010, there was flood in Pakistan and also flood in Northwest India. In both the years, climate models predicted normal monsoon. We had a severe drought in one year. We had almost a flood in another year. So what does it mean? Indian monsoon, in summary, is a robust climate system, and its interannual variability is governed by large-scale atmosphere-ocean patterns. Droughts and floods have occurred irregularly throughout a 200-year excellent data set. Indian monsoon appears to exhibit a decadal variability with approximately 30-year cycle. Indian monsoon, and by extension Asian monsoon, is not impacted by global warming at this point in time. I think global warming forcing is too meager to disturb this huge, robust atmospheric system. A conceptual drought flood model that I have developed here provides an operational technique to say ahead of time, few weeks to few months, if the next monsoon would be very wet, very dry, or in between, and can provide a suitable adaptation technique. That's all. I'd like to thank the Heartland for inviting me for this conference. It's a great conference. I'm enjoying it. I also like to thank my wife, Shalon, who is sitting in the audience, for preparing this very useful slide. She has helped me a lot with this. Thank you very much.